Oh, hey there. Today we're talking about some crap that's going to blow your mind out the back of your skull. That's right, Xbox are literally redefining what's possible on your next generation console. What is happening, guys? Dealer back again with yet another video talking about some really incredible technology. Not only that, but we've got a demo of velocity architecture, sampler feedback, and we're going to be covering a lot today. This is really cool because it will literally change the way games are built. It will also change what you see. This is one of the biggest things about the next generation Xboxes that current consoles, or rather last gen consoles, could not do, impossible. It just wasn't gonna happen. Again, this is the feature I was referencing in my last video, the one I spoke on 2 years ago, and it's quite incredible. Not only does it free up more performance for the Xbox consoles, meaning they can punch well above their weight, which is already quite substantial, but it enables developers to leverage even more memory, more bandwidth efficiently. And we've got, again, all the information right here for you. So if you end up liking this video, maybe hit the like button, show a buddy or two. It really helps. Thank you for getting me to 100,000 subscribers. It's 100% you guys. And for those of you asking me to cover this, yeah, let's get into it. Now, it all started with Microsoft's GameStack Live event where, hey, they're telling developers what they can look forward to, the features, the new tools that are available in the Xbox Series consoles, and some developers have already leveraged these tools, though no games today have done so. Again, this is one of many technologies, one of many tools, quote unquote, that developers will have. This is just one.
The scene you're looking at was built to a very high level of detail so that the objects can be inspected up close. Over 10 gigabytes of texture content are present in this scene, and we use texture streaming to hold only some of that content in memory at any given time.
This could help something like the Xbox Series S, not to mention the X, save substantial memory usage here. 10 gigabytes becomes more like, well, multiples according to their own math here. This is developers, not just Microsoft. Developers, real-life developers, speaking on the memory multiplier effect of velocity architecture. So take notes.
The texture budget is the largest single user of title memory and the largest single user of storage. We can estimate what an optimized Generation 9 traditional texture streaming engine would need to have in memory to render what you're seeing right now. It's still a conservative estimate, by the way. Most game engines would likely use somewhat more memory than you see here due to overstreaming. But with sampler feedback streaming, we can use significantly less memory to render the same scene, and a corresponding reduction in the amount of storage we use to load the data into memory.
Now, I just want to say something real quick. This dude is knocking it out of the park. I've never seen such fine handiwork. Seriously though, I think it's cool that they got somebody here translating in sign language. Pretty cool.
That means that for the same scene, we're loading it faster on Xbox and using less memory than on competing platforms.
Hey, this means that, what I got this auto-tune on for? Yeah, I got an auto-tune mixer. Now, what is a competing platform? Is the Ouya, the Etch-a-Sketch, it's not PC. I mean, they are PC. It's PlayStation 5. They're saying they're using less memory. They're more performant than PlayStation 5. This means Series X with its 16 gigabytes of total memory, right? Obviously, there's like 13 for games. But on top of that, they just said it themselves. Look, with velocity architecture, we effectively had much more than the 13 gigabytes for games, right? Let's just call it 16 because that's the total memory. Let's just say that. With Xbox Series consoles, you are no longer limited by the physical amount of memory on the motherboard. That's what they're saying right now. I remember people laughing when I was talking about how they're going to redefine how memory is gauged, how it's used. And it's all through the magic of how they've integrated the SSD, the RAM, the APU, and accelerated all that with their custom decompression blocks. It's pretty awesome.
Efficiency gain as a multiplier on our storage performance and our graphics memory size. With this view of the scene, the value is 3.0. I should also mention the absolute numbers you see in the memory bars here. They aren't all that high, especially compared to the 10 or 16 gigabytes of memory in our consoles. The comparison between sampler feedback streaming and traditional MIPS streaming holds true regardless of material complexity. The numbers will scale with content, and the multiplier will still ring true.
So So as you see there, they're using a fraction of the amount of memory that they would normally be using. And this is what I've been talking about with the Xbox Series S. When developers are talking about memory limitations, not only is that kind of odd considering their game would be on PC 99% of the time, and that minimum spec would be far less than what Series S offers, but they never really mentioned the velocity architecture, sampler feedback, all of these things that I've been talking about, the reasons why Series S's memory will not hold back next generation games, as several developers have confirmed, though there are some that doubt this would be the case.
Let's compare a Generation 8 traditional streaming engine on a hard drive to sampler feedback streaming running with the Xbox Velocity architecture. I'll start the scene reload now. This camera angle consists of over 2 gigabytes of texture data and simulating a hard drive from the Xbox One X console. From talking with title developers, we know that texture streaming is as much art as it is science. Various techniques are used to estimate scene visibility and size for each object. Most titles do complex offline processing to make these estimates better.
Now, what he means by complex offline processing, right? Meaning it's not real time. These calculations are already pre-done, either in a loading screen or some other method. This is no longer going to be the case, or even needs to be the case, rather, as he will explain.
After about 22 seconds on a simulated Xbox One X console, we're done loading. We reload the same scene using sampler feedback streaming from our solid-state drive. It takes less than a quarter of a second.
Guys, really, this is just raw speed without any kind of tricks, just a pure example of what Velocity architecture is going to be doing on Xbox Series consoles.
Sampler feedback uses the GPU to automatically determine the exact set of texture data needed to render the scene with the ideal level of detail. Our solid-state drive, hardware decompression block, and optimized direct storage API gets that texture data into memory extremely quickly. Additionally, you rarely see pop-in artifacts. When you're playing a game, sampler feedback streaming allows you to move quicker through the world with higher detail. And since everything loads so quickly, game developers don't have to use twisted hallways between areas or loading screens to cover up texture streaming.
You remember those things where you walk in between two rocks and you're like, man, these are really nice rocks because I gotta walk real slow. You know, hidden load screens, right? Yeah, with Velocity, loading is essentially a thing of the past, at least for the most part. And this is the cool thing, right? No game right now leverages Velocity architecture like this. None. He also did talk about the lack of pop-in when using this Velocity architecture. This is the tip of the iceberg when it comes to Velocity, the basic benefits so far. We're not even talking about game design yet.
There is a ton of detail in this scene. When you get close to the drawings, you can see the texture of the paper as well as even the pencil strokes.
Look, I don't know which one of you guys colored this. This is horrible. But what I will say is that it's pretty sharp for how close they are to this. Think about it. In a normal game, you are several times further back, at least from a camera perspective, and it's nowhere near this sharp. With Velocity, this is no issue to render in real time in your games. And if it could do it to a piece of paper, what else do you think it could do it to? That's right, just about anything.
And you can see how the memory usage changes as I look at different parts of the scene. You'll note that the memory bars in the upper right-hand corner consist of both a light region and a dark region.
Now, some of you are wondering, why is the memory usage fluctuating so much? Well, that's part of sampler feedback. What isn't on screen will not consume memory for the GPU. It will remain on the SSD. This is where fetching items very quickly off of the SSD, well, that's kind of the point of Velocity, and how it works is quite amazing. I remember talking about this years ago, smart rendering GPU features that will save on performance and RAM usage by not rendering things that you actually don't see. That's a big part of GPU culling. That's a big part of sampler feedback. That's a big part of Xbox Series X and S. Once more, this will help performance and RAM usage. Another boost for the series consoles.
The streaming system is constantly unloading memory that hasn't been needed for a few seconds. I can even do quick camera cuts, which are difficult for most texture streaming systems to handle. Each time I perform a quick camera cut, over a gigabyte of new texture data can come into view. Thanks to sampler feedback streaming, only a fraction of that data needs to be loaded.
He said it himself, only a fraction of that data needs to be loaded, meaning a system like Series S VRS, the one with the bottleneck in the memory, would be far more performant. That 7 or 10 gigs total would be far more effective because you can use more of it for more of what you need. So shout out to everyone who thought I was lying or damage controlling on that one. It was few people, but some people can't read.
Some games have to have a lengthy load screen, transition effect, or some sort of contrived gameplay element to hide the texture pop-in from a quick camera cut. This tech demo doesn't have any of those tricks. Sampler feedback streaming is really that fast. I've switched the scene rendering to color code the amount of detail used at each location, from red representing the most detail to purple representing the least amount of detail. Each texture in the game is implemented with multiple levels of detail called MIP levels. MIP levels are used to increase performance as well as improve image quality when objects are drawn far away from the camera.
So this is basically level of detail shifts, but much faster, much more detailed, much more capable, thanks to the enormous amount of data that the Velocity architecture can handle. It's simple. As you get closer, things get better looking. What you don't see, you don't notice, and so on and so forth.
The texture streaming system can choose to unload the more detailed MIP levels when they're no longer needed. Note that these MIP 0 images are rather large. Even with a solid-state drive, it is a consequential decision to load 16 megabytes just to see detail for one texture on one object.
With Velocity, this multiplies the effectiveness of the memory in the console. The SSD is the big part of that, but he's about to tell you why Velocity architecture is so cool. And even though there's not a single finished game out there on PC right now that requires an SSD, especially in M.2 of this speed, he's saying that we can go beyond that even if that were the case with Velocity.
With sampler feedback streaming, however, it's more responsive because it very quickly loads the detail only where it's needed. It's more efficient. Think about standing next to a building or a statue in a game. Sampler feedback streaming allows you to see incredible detail up close, like the placard on a statue or the face on this drawing. And it doesn't waste time or memory loading unnecessary detail far away from the camera or off screen. With sampler feedback streaming, games can add more detail to every object, large and small, and not have to worry about compromising their entire texture budget elsewhere to make it work.
Texture budget, meaning your ceiling. How much space do you have in the RAM? Now think about it as, well, instead of higher resolution assets, on something like a Series S, it's really meant for 1080p. We're going to actually use some of that saved space for our game design, right? What we're held back by, quote unquote. There's just more RAM available because what is there is being smarter utilized, as explained.
In this camera angle, the Pacific Ocean on the other side of the globe is not loaded in yet.
This is represented up here in this black box. So the black areas here are areas that the system is not bothering to load into memory, freeing up that memory space, meaning that this area that is loaded into the memory can actually be more detailed than it would ever be possible before. Not rendering what you cannot see, not putting into RAM what you do not need, bringing up and making more effective the RAM that you do have.
The streaming system quickly loads in the newly visible parts and unloads the parts that are no longer visible. Think about an in-game cinematic when you see a character's face up close. Sampler feedback streaming allows that character to have incredible detail loaded extremely quickly and not waste time loading detail on the other side of the character you can't see. On the left is a visualization of sampler feedback data for this one texture. Sampler feedback is configured per texture, and we are looking at just one of the 475 textures in this scene. The texture is divided into regions, and the developer chooses the size of the regions. For each region, the GPU computes the ideal level of detail used to sample the texture within that region.
So developers can essentially flag assets, right? Texture regions, and tell the GPU, hey, this one needs to be red, meaning high detail, right? I'm just going to use this as an example. This one needs to be purple, not a lot of detail. It's not really all that important, and you really can't see it anyway, or it's in a shaded region, and so on and so forth. They can tell the GPU what to put the horsepower on. This is actually kind of like VRS, but more related to texture streaming, and again, does save you on performance.
As I approach and pull back from the drawing, you'll see regions of feedback show higher and higher levels of detail. Gray represents no feedback. That's because those regions are now off screen. The GPU is capable of providing an enormous volume of sampler feedback data, and we can carefully tune the level of output to best balance accuracy and performance. We have found that we can discard over 99% of the raw data and still get great results.
You guys heard that right. That 99%. They can get rid of 99% of what they don't need, which I'm pretty sure if you get rid of 100%, it's technically better, but I'm pretty sure you would see nothing. I'm pretty sure it would just be nothing on the screen. So again, 99%, exceeding expectations of myself, definitely. That's incredible. And I would assume this best case scenario, again, 100% nothing, right? Once more, it allows developers to, put all the processing and bandwidth towards what they want you to see, what their artwork is all about, and not a bunch of crap in the background that no one can even see because there's a depth of field effect over it. This really trims the fat.
Game developers have lots of ways to control the precision and amount of data coming from sampler feedback. Each title can tune sampler feedback to best suit their needs.
Now that you've seen the benefits of the Xbox Velocity architecture, you can see...
Man, this is just one of the technologies they're talking about at GameStack. I will be covering more as time goes on, and seriously, if you want to keep up with the latest on this, if you want to maybe learn more, or at least from what I understand of it, feel free to subscribe, as I will be covering everything when it comes to Xbox. And again, Velocity architecture, absolutely phenomenal. Gets rid of the traditional rules of memory, at least that of which is bound on the physical motherboard of the console, and frees developers to do whatever they want, provided they want to use Velocity architecture. It is optional. Now, you might be thinking, well, developers don't really have an incentive. PS5 doesn't really use it. The Xbox One doesn't really use it. Why would you want to? Well, simple. PC gaming is a massive market, and RDNA 2 graphics cards, as well as NVIDIA graphics cards, will be using direct storage, as it's now called. This is all part of the DirectX 12 family, the Velocity architecture. These APIs will work one and the same ultimately, and when you tune a game like this on Xbox or PC, it works pretty much vice versa. So yeah, PC gaming will help push this onto console. And of course, when developers get a little bit more time, they catch up on current projects and start work on new projects, through this pandemic. They will definitely start leveraging this stuff as their ambition rises, right? They want to see what this stuff can do, and so do I. Let me know what your thoughts are down below. Velocity architecture is the real deal. Again, appreciate everything you guys do. Share the video out. It really helps. It's the only reason they even go anywhere. And of course, let me know your thoughts in the comments. If you haven't, maybe hit the like button, tell a buddy or two about the channel. Check out the last video. Sources down below. I'm Dealer, and of course, I will see you in the next one.